Okay, hi everyone. I've decided to make my face much bigger for this, so you can look at how beautiful I am. No, I just thought I'd fill up a bit of space and you know try and make this a bit more engaging. What we're doing today is we're talking about doing simultaneous equations with matrices. So what we're going to look at is let's say that let me get an example from the book. Good idea. We'll start with an example from the book. So you've already watched my video on standard simultaneous equations. It's very similar to that. We're just going to put it into matrix form. Go. Inverse. There you go. Simultaneous equations. Let's just get let's take a random example from here. Let's say we have 4x minus 3y equals 10 and 3x plus y equals 1. All right, so that's my equation. Now, the first thing I want to do is translate this into matrix form. So what you need is a matrix that has just the numbers in it on this side of the equal sign, multiplied by a matrix that has just the pronumerals in it, equals a matrix that has just the answers in it. All right, so let's have a look at that. So I'm going to put all these numbers in. So we have 4. Make sure you bring this sign in. So -3, 3, and if there's no sign, it means that there's a 1. If there's no y, if that's missing, it just means that this value is a 0. And I'm going to bring in those pronumerals, and it should work out so that if you were to multiply these out, this row times this column, it would become 4 times x and minus 3 times y. All right, so it sort of fixes itself. And then our answers go in here. Now, I talked about in the inverse video and in the inverse class that if you have an unknown matrix multiplied by a matrix that you do know, that you can't just divide. So instead, you find the inverse and multiply the inverse by the answers. Okay. So what we ideally want to get to is something like this, where we have xy equals the inverse of this. All right, the inverse of that times your answer. All right, that's ideally how you want to get there. I just dropped my pen, so all right. So that's what we really want to do. So I'm going to show you how to do this on the CAS. I already showed you how to do inverse by hand in that other video, so there's not really much point. Basically, what you want to do is go to the square matrix. So I'm down in the bottom left, I think, at the moment. Square matrix, and we're going to type in these values here. So 4, -3, 3, and 1. All right, so that's our matrix, and we're going to raise that to the power of -1. All right, so this is our inverse. So we have this multiplied by our answer matrix, which was a column matrix with 10 and 1 in it, and that should give us our answers for that equation. So we had 1 and -2. Let me check the back of the book and make sure we got it right. 5. So we have 1 and -2. There we go. 5J, question 3, 1 and -2. Right? And that's as easy as it is. I'll do another example. I'm just throwing my pen on the floor again. With a 3x3 matrix, I guess. I don't think they'd have an example of this in here for me to look at, probably. No, they don't. That's okay. I'm just going to make it up then. So we'll say I've got x, y, and z, which have the values of 1, 2, and 3. Right, so they're the answers that we're going to want to try and get. And I'm going to write out 3 equations. So I'm going to have 2x plus 3y minus z equals something. We'll say 2x plus 3z equals something. And we'll say 2y minus z equals something as well. All right, I'm just going to quickly solve these. So 2 plus 6 is 8, minus 3 is 5. 2 plus 9 is 11. And 4 minus 3 is 1. All right. So assuming that I've figured this out correctly, these should be our answers that come up. So this time we have 3 equations, so we need to make a 3x3 matrix. So let me push this up a little bit. So we put it into matrix form again. And we have 2, 3, negative 1. 2, this time there's no y, so we're putting in a 0. And 3, this time there's no x, so we're putting in a 0, 2, and negative 1. All right, and our values here are x, y, z. And our answers are 5, 11, and 1. All right, so again, what we're going to do is we're going to find the inverse of this and multiply it by this. So inverse of that times that. So let's go on to the CAS now. And we'll make a 3x3 matrix. We enter 2, 3, negative 1, 2, 0, 3, 0, 2, negative 1. I'm finding the inverse of that multiplied by our answer matrix, which was a 3x1. What's going on here? Sorry, try that again. Multiplied by our answer matrix, which is a 3x1. So it's 5, 11, and 1 in it. And hopefully, if we did this right, we should get the answers 1, 2, 3, which is what we've got. All right. So of course, you won't be given that information generally. All right. So our values x, y, and z are 1, 2, and 3. So yeah, that's how simultaneous works with 2 and 3 equations. So the number of pro-numerals always needs to match the number of equations, I guess, is the only advice I can give you. You could potentially do 4 if you really wanted to. Yeah, hopefully you enjoyed that.